So we're going to look at mixed operations with rational expressions, and mixed operations with rational expressions are very similar to what we've been doing in the past, say, week and a half or two, which is operations with rational expressions. So steps are very similar to what we've done before. So first we factor all numerators and denominators, which is kind of like standard procedure for us now, factoring everything. We state the non-permissible values because these are rational expressions. The denominator cannot be equal to 0, so we state what values of the variable would make the denominator 0, and then we will not accept that. Because these are mixed operation, we follow BEDMAS, right? Because there's addition, subtraction, division, and multiplication involved, then we follow BEDMAS. And BEDMAS is going to be sort of our guiding procedure to have some sort of a normalcy in this, and some way of actually checks and balances, so the things are sort of working out for us. And then at the end of it, we simplify everything. At the end of everything, we simplify, and we come up with one simplified version of our solution. So we're going to follow those steps to do this example 1. I have x minus 2 over x plus 5. There's nothing to be factored. So for our first step, the first fraction that we have, the first rational expression, has nothing to be simplified. The second one, though, can be factored. Both the numerator and the denominator are factorable, or they're trinomials that at least look like they could be factorable. Okay, what two numbers multiply to make negative 3 and add up to make negative 2? How about negative 3 and positive 1? We do the same thing for the denominator. We go, okay, what two numbers multiply to make negative 6 and add up to negative 1? Okay, how about negative 3 and positive 2? Okay, and then the last rational expression is x squared plus 2x over x squared minus 4x. X is a common factor in the numerator, so I'm left with x plus 2. Same thing, there's a sort of a GCF, greatest common factor, in the denominator that we factor, and that's x, and we end up with x minus 4 as the other factor. Okay, so at this stage, we're going to state the non-permissibles. So, okay, these are non-permissible values of x. X cannot be equal to negative 5, because if x is negative 5, the first rational expression is going to be undefined. It's going to be a division by 0, and that's no good, right? For the second rational expression, we have these two. If you set them equal to 0, then x cannot be equal to 3, and x cannot be equal to negative 2. We've gone through this stuff before. You know this, the procedure for this. This is pretty standard for us now. For the last rational expression, I have x cannot be equal to 0, and x cannot be equal to 4. So those are non-permissible values. We stated all of those. We've listed them, and we move on. Step 3, we follow BEDMAS. If I follow BEDMAS, BEDMAS says do multiplication before addition and subtraction, right? So this multiplication would have to be done before this addition on the left. So that's what I'm going to do. So I'm going to go x minus 2 over x plus 5 plus, if we do this operation here, then I have the numerators multiplying to each other, x minus 3 times x plus 1 times x plus 2. And the denominators are going to be x minus 3 times x plus 2 times x plus 4. Then we go, okay, what can be simplified in this big giant fraction? We go, okay, x minus 3 is common between the numerator and the denominator, so they cancel out. These two x's are common, and they cancel out. X plus 2 is common between the numerator and the denominator, and those cancel out. So I end up with the next step, which is step 4. Actually, we're still in step 3, which is following bed mass. So we stay in step 3. Now, our second rational expression ends up to be x plus 1 over x plus 4. Was it x minus 1? Where did we, or x minus 4, sorry. I miswrote it, right? Okay, good. So now I have these two, and I'm adding two rational expressions. I need an LCD. I need the lowest common denominator. So we list all the factors of the denominators, x plus 5 times x minus 4. The highest powers of those two, which is 1. So that's going to be our LCD. So for the first fraction, it is an x plus 5. It needs to become x plus 5 times x minus 4. Numerator is an x minus 2. So we also have to multiply that by x minus 4. Okay. The second fraction, it is an x minus 4. The top is x plus 1. But we need to multiply the bottom by x plus 5 to make it the LCD. We need to do the same thing to the numerator. Now we have common denominator between the two fractions, x plus 5 times x minus 4. The numerators, I have x minus 2 times x minus 4 plus, this plus here goes up there, x plus 1 times x plus 5. Expand the numerator and see if we can simplify. So this will be our step 4. Okay, this becomes x squared minus 6x plus 8 plus x squared plus 6x plus 5 over x plus 5 times x minus 4. Now we go after combining like terms in the numerator. There isn't really much to do in the denominator, so we just leave it as it is. The 6x and minus 6x cancel each other out. So we end up with x squared plus x squared, which is 2x squared, and then 8 plus 5, which is 13, and that's the most simplified version, and we just leave it at that. Okay? Now we're going to go to another example. So example 2, I'd like you guys to write this down and do it before I do it. I'm going to take the first step for you and go, okay, this is x plus 1 over x plus 6 minus, I'm going to factor everything. X squared minus 4 looks like the difference of squares, so I'm going to factor it. This is x minus 2 times x plus 2 over, there is a common factor between x squared and 2x, and that is an x. We factor that out. It becomes x plus 2 divided by, the numerator can be factored. This is 2x and x, and we end up with 2x plus 1 and x plus 3, I think, should be. Or you guys can follow factoring by decomposition and factor that. And then in the denominator, if you factor out the x, you end up with 2x plus 1 as the other factor. So I'd like you guys to go through the rest of it and simplify it, and then we'll come back to it in a minute. Okay. Okay, so to state the non-permissible, so this is our step 2. For the first rational expression that we have, x cannot be equal to 6, otherwise, or x cannot be equal to negative 6, otherwise x plus 6 becomes 0. For the second rational expression, x cannot be equal to 0, x cannot be equal to negative 2. For the third rational expression, x cannot be equal to 0, but we already have that, so we don't have to repeat that. For 2x plus 1 cannot be equal to 0, then we go, okay, x cannot be equal to negative 1/2. You can go through solving that simple degree 1 equation and come up with the answer. I'm pretty sure you guys all know how to do that. But if I flip this to make it into a multiplication, when I make this into a multiplication, I have to flip this fraction. If I flip the fraction, the numerator, which is 2x plus 1 times x plus 3, becomes the denominator, right? So therefore, we will have another non-permissible, which is x cannot be equal to negative 3, which is coming in our next step. So x plus 1 over x plus 6 minus x minus 2 times x plus 2 over x times x plus 2, make it a multiply, flip the fractions or reciprocate the fraction or the rational expression. X times 2x plus 1 goes to the top, 2x plus 1 times x plus 3 goes to the denominator. So this last non-permissible that we have is for this. Yeah? Now we start sort of simplifying. BEDMAS says do the multiplication first. So with the multiplication that we have, we're going to start simplifying what's common between the numerator and the denominator. X plus 2 is common between the numerator and the denominator. X is common between the numerator and the denominator. 2x plus 1 is common between the numerator and the denominator. So we end up with x plus 1 over x plus 6, right, minus, this is our step 3, doing the BEDMAS business, x minus 2 over x plus 3. Okay? So now we have two rational expressions. We need an LCD because this is addition and subtraction. The lowest common denominator again is x plus 6, x plus 3, all the factors of the denominator with the highest power, right? So I can write these two as two fractions, x plus 6, x plus 1 over x plus 6. The denominator has to be x plus 6 times x plus 3, so I need to multiply the top by x plus 3 as well. Second one is an x plus 3 in the bottom, or in the denominator, and x plus 2 in the numerator. The denominator has to be x plus 3 times x plus 6, so we multiply the numerator by the same thing. So I can combine the two rational expressions because they have common denominator now. Then I'm going to expand these guys. It becomes x squared plus 4x plus 3 minus, and I'm going to expand these guys. This is x squared plus 4x minus 12 . I'm going to apply that negative here and simplify everything. So I have x squared plus, that's a 4x, not 46. 4x plus 3 minus x squared minus 4x plus 12 over x plus 6 times x plus 3, and this is our step 4, which is simplifying everything. Now we go through simplifying everything. So combining the like terms, the x squares cancel out, and the 4x's cancel out, and you get 12 plus 3, end up with 15 over x plus 6 times x plus 3. And that's the most simplified version that we could come up with. Now we're going to look at something that looks more complicated, right? But if you just do one thing to it, it becomes actually a lot simpler looking, right? So it looks more complicated because like it's a sum of two fractions over a fraction of like the denominator being sum of two other fractions. So I'm just gonna rewrite it as something else, and you guys can see that it simplifies to something much easier looking. I'm gonna write it as a division of these two statements. Okay, so I'm going to write it as division of these two statements. So again, we're going to like follow BEDMAS. This is, well, we could have factored that, but we'll factor it in the process. So we're going to follow BEDMAS and do the operations inside the brackets first, right? And that will simplify it. So we go, okay, the common denominator is x plus 4 times x minus 4. The numerator of the first one becomes x minus 4. The numerator of the second one becomes x plus 4. That's divided by, this is x minus 4 times x plus 4 for the fraction. 1 over x plus 4. If you were to make a common denominator, we need to multiply the denominator of the second fraction by x minus 4. To do that, we need to multiply the top by x minus 4. Okay, so we end up with, here the 4's cancel out. I have 2x over x minus 4 times x plus 4, and divided by, oops, there was an x here, divided by, here I'll combine the two rational expression. I have x minus 4 times x plus 4. So from the first fraction I have x, from the second fraction I have x minus 4. So 2x over x minus 4 times x plus 4 divided by 2x minus 4 over x minus 4 times x plus 4. So now, we have the division of the two rational expressions. We're going to make it a multiply and flip the second fraction, reciprocate the second fraction. X minus 4 times x plus 4 goes to the numerator. The denominator becomes, let's take a factor, 2 times x minus 2. The first rational expression stays the same. Now we see that x minus 4 times x plus 4 is common in the denominator and the numerator, so we can cancel all of that out. And we end up with canceling 2 from the numerator and the denominator, and we simplify it to x over x minus 2 as our final simplification form. And this is your H work for this section, so go ahead and make a note of that. Go ahead and make a note of that.